And welcome again. Let's calculate the capacitor of a capacitor system, capacity of a capacitor system. You can read the statement of the problem that is given as the plates of a spherical capacitor are a metal ball of radius r1, as you can see here, this metal ball of radius r1, and a concentric metallic sphere with internal and external radii r2 and r3. The plates are connected to a voltage source. How the inner plate is connected like this and the outer plate like this. After charging the capacitor, the ball is grounded. That means this ball is grounded. Okay. Using the key, this key, and a thin long insulated wire passing through a small O. That is the process how the ball is being grounded. And now determine the equivalent capacitance of the capacitor system. So this is the problem, and we need to solve it, and of course we can solve it because it seems to be a very small problem. As we know, we consider the earth potential to be zero. That is what we call it. We assume the potential of the earth equal to zero. And after grounding the ball, the potential of the sphere is equal to something after grounding the ball. The potential of this sphere becomes simply U, and because it's a metal plate, metal sphere, so the potential of the whole outer sphere will become U, both relative to infinity and relative to the inner ball of radius r1. It will become U. Now we have basically a capacitance here. It is at lower potential and it is at higher field potential, and we have another potential solitary sphere of radius r3. It's a solitary sphere, isolated sphere, we can say, and of radius r3, and of course the capacitance of this system, this ball and this inner sphere, is C1, and it can be written as simply as 4 pi epsilon naught r1 r2 are their radii divided by r2 minus r1. And the potential of this solitary sphere we can write as C2, and that is 4 pi epsilon naught R3. And if you like, you can make an equivalent circuit containing both the capacitors, and you can find the total system capacity. And what is this? We have first of all, if I try to draw an equivalent circuit for this capacitor system, I would like to draw first the source of voltage source U, and I can see here, and with this voltage source, the capacitance C1 is connected. You can see here with this voltage source, capacitance. This is also connected to this, so this capacitance C1 is connected, and then you can see that and this capacitor is also connected, C2, because I earlier told that the potential of the sphere this sphere, this sphere is equal to u, both relative to infinity and infinity to the inner ball. Inner ball is this. That is why we have a system like this, equivalent capacitance system, and we know that the equivalent capacitance of the system can be simply found as simply adding them C1 plus C2 because they are in parallel. And now you can get your result simply as this. You are free to calculate this. So thank you very much for watching this problem 2.